Hi everyone! When given an indefinite integral exercise, you may feel overwhelmed questioning yourself with how do I begin? So I'm going to give you some examples to help you design your strategy on how to work with this kind of exercises. Let's begin. Let's consider this first example. So observe that we have a rational expression here, and there's like a lot of going on here. So there's a big chance that here you should use a u substitution. So we have to figure out what we're going to name u, okay? So my advice here, when you have this kind of exercise, is that the candidate for naming u is going to be what is inside of a parenthesis, or what is inside a radical, or inside an absolute value. So I'm going to choose the expression here, raised to the power 2. This is going to be what I'm going to name u. Okay, so u is going to be x squared plus 2x plus 4. And of course, since I'm going to do a change of variable, everything here is going to have to be in terms of u. Okay, so I need to figure out what du is going to be, the differential of u. Okay, so what do you do after this? You differentiate. Okay, so on the left side, so the derivative of u is going to be 1, so 1 du, the differential of u. And on the right side, I'm going to find the differential of x, which is going to be 2x plus 2 dx. Okay, so you differentiate and you put the differential with respect to the variable that you're working with. Now we use substitute. So I name this u, so since this is squared, I'm going to replace this to u squared. And I'm left with x plus 1 dx. And I don't have it directly here, but when you find that you don't have exactly what you need in the replacement of du, then probably you should factorize or simplify somehow. So I observe that I have a common factor here. So let's factorize. So this is going to be 2 times x plus 1. And now I have the x plus 1 dx that I need. Okay, so what is x plus 1 dx? If you divide by 2, x plus 1 dx is going to be du over 2. Okay, so this expression, I'm going to write it as it is, so it's going to be du over 2. But dividing by 2, remember that is the same as multiplying by 1/2. So I'm going to write it as a 1/2 du. And now we just integrate. So I have a coefficient here. My advice is take it out. So this is going to be 1/2 the integral of u 1 over u squared du. And when you have this kind of expression, my advice is to write it in exponential form. So saying 1 over u squared is the same as saying u to the power -2. Okay, so if you write it like that, then you're going to be able to use the exponent rule for integration. Okay, so just adding 1. So that's exactly what I'm going to do here. Okay, so this is going to be u to the -2 plus 1 over -2 plus 1. And of course, this is an indefinite integral, so remember to put the constant to represent all the antiderivatives of this expression. Okay, so simplifying a little bit, this is going to be u to the minus -1 over -1. Okay, so this is -1/2 times -1, which is going to be -1/2. And this is to a negative exponent. Okay, so we rewrite it as a positive exponential form. Okay, so this is going to be 1 over u plus c. But remember, we didn't differentiate, we didn't integrate in terms of u. We're working with x, which is the initial expression here. So we use the u as a helper to get to the final result and then go back to the variable that we were working with. So remember that the last step is always going to be go back to x in this case. Okay, so this is the same as saying -1 over 2 times u is 2u, but I'm going to write it as the expression that I name u, which is going to be x squared plus 2x plus 4. And of course, to represent all the antiderivatives, obviously the plus c. Okay, remember that c represents all the constants that differ between all the antiderivatives. So this is the result for this example. Now, when you have find an integral that involves trigonometric functions, probably, you should either use or use substitution or probably one of the identities that you learn in trigonometry. Okay, so here when I have too much going on. So that most of the times is the key for knowing that, okay, maybe I should do a use substitution. I have a lot going on. Okay, so I have to decide who am I gonna call you, okay? So here, I'm going to decide that I'm gonna call you cosine of 2x, okay? So I'm gonna name you cosine of 2x and see what happens. Okay, so cosine of 2x, then I find the differential. So this is gonna be, and remember, cosine of 2x. So that's gonna be a chain rule there, okay? So the derivative of cosine is negative sine of 2x, and then I go here, and the derivative of 2x, which is gonna be 2, okay? Now, obviously, the differential of x. Now, I start replacing here, but I notice that I can replace this as u, but I don't have a sine of 2x here. But I do remember from trigonometry that this is the same as saying, so I have the negative 2 here, and here, this is the same as saying 2 sine of x, cosine of x. So in other words, we have here a negative 4 sine of x, cosine of x. So I have exactly what I need. I have sine of x, cosine of x dx, which is exactly what I have here. So if I solve for that expression, then I'm going to have what I'm going to replace here. So I'm going to divide by negative 4. And then I know that sine of x cosine of x dx is going to be negative du over 4. So I'm going to write the du here. And I can either write it as a divided by negative 4 or as a negative 1 over 4. Okay? Now I can integrate. So as I said before, this is a coefficient. My advice, take it out. So this is going to be negative 1 over 4, the integral of u du. And this is the same as u to the power 1. So I can use the power rule for integration. So adding 1. So this is going to be u to the 1 plus 1, which is 2 over 2, plus c, of course. And just finish it up. So multiplying here, I have a negative u over 2, u squared, and 4 times 2, which is a plus c. But remember, as always, the last step, go back to x. In this case, x, because it's a variable of integration. So what was x? What was u? This is cosine of 2x. So cosine squared of 2x over a plus c. And there we go for this example. Now for this integral here, we have an expression raised to the power 2, an expression squared. And in those cases, my advice is going to be just expand it. Okay, so to the power 2 is not hard to do, so just expand it. Most of the cases it's going to be just using the power rule. Okay, so that's what I'm going to do. Remember, then when you expand here, this is going to be the first term squared. So it's going to be 3 squared, which is 9, square root of x squared, which is going to be x, plus, here it says plus, 2 times the first to the second. So it's going to be twice the first term times the second term, plus, and the second term squared, which is going to be 16 here. Okay? So I'm going to simplify a little bit, and we have a 9x plus 6 times 4, which is 24, square root of x, plus 16 dx. Okay? And now this whole expression, I just go individually integrating using the rules accordingly. Okay, so remember what I have said previously in previous videos. So my advice, when you have a square root, just write it in exponential form, which is going to be x to the 1/2. Okay, so after I do this, I just start working individually, integrating each term. Okay, so let's go. For the first term, okay, so I have the coefficient and the antiderivative of x, and adding 1, which is going to be x to the power 2 over 2, plus, see, I have a plus here, 24, which is a coefficient here, and the same deal here. I'm going to add 1. So I have x to the power 1/2 plus 1, 1/2 plus 1, which is going to be 1/2 plus 2/2, finding the common denominator, and this is going to be 3/2. Okay, so this is to the power 3/2 divided by 3/2. Remember that it's the same number here, plus, and the antiderivative of 16. Remember that when you have a constant, it's the constant times the variable. Okay, so since the variable here is x, the antiderivative is going to be 16x. And since it is an indefinite integral, we're going to put the plus c representing all the constants of all the antiderivatives. and simplify a little bit, okay? So here we have 9/2 x squared. Dividing by 3/2 is the same as multiplying by the reciprocal. So dividing by 3/2 is the same as multiplying times 2/3, x to the 3/2 plus 16x plus c. Okay, and I'm just gonna finish it off here multiplying. So this is 9/2 x squared. So 24 divided by 3 is 8 times 2, which is gonna be 16, 16x to the 3/2 plus 16x plus c. Okay, so if depending on your final answer, if you can go back to radical form. Okay, so for 3/2, just remember the definition that this is gonna be this guy here, and since this is square, I don't need to write it. Okay, so this is the same as saying the square root of x cubed, which you can simplify a little bit more since this is gonna be x squared times x, and here to take out the absolute value. So this is gonna be the absolute value of x times square root of x, and you can write it here if you need to write the final answer in radical form. Okay, so this is the answer for this integral.